There's one thing. I'm putting this in this is a little shaky because I already put the tripod away that I was using to mount my little camera on, and I remembered there was something very important that I thought I should mention, and I forgot all about it. And that is, you see this secondary mirror, the Gregorian secondary right here. That's in the example I'm using. It's 4 inches in diameter and a focal ratio of f4. And the primary mirror, which is right back here, was that was f4.5. I should mention that this mirror has to have a faster focal ratio than the primary. The reason for that is, see the distance right here between the point B and here? That's the focal length of the telescope right there, if you use that as little mirror as a Newtonian reflector. And you notice that this distance between A and the surface is a little bit longer than that. So that these light rays right here have to expand out a little bit farther than they would if the distance were between A and the surface were actually between B and the surface. So that means that they expand out a little farther, and this distance is greater than it would be if you're using this B coincided with A. So that means that these rays, if they're going to intersect inside the actual outside edge of this mirror, have to have a shallower angle right here, a shallower angle than they would for the actual this mirror right here, like as a Newtonian mirror. So I'm moving the paper along by using the pen there in a rather clumsy way. So anyway, what that all means is that, like, if let's say this primary mirror is around f5 or f6, it would be a good idea to use an f4 secondary mirror as a commercial mirror. And if you have a really fast primary mirror, you'd have to have an even faster secondary mirror. So let's say you use an f5 primary mirror back there, then you would have to use probably an f4 mirror right here. Okay, and that means that all these outer rays right here will be captured inside the surface of this mirror. Okay, so I hope it's hard to explain this. I'm not very clear at explaining things sometimes, but that's basically what's going on. So what I'm going to do is I'm going to be putting 3 videos on separately, probably over a period of about 3 days. My computer takes, as an old 11-year-old computer, it takes a long time to upload one video. So it'll probably take 3 or 4, maybe 5 days for me to get around uploading all 3 videos. But I'll do it eventually, so you'll have to bear with me. And all this information will be in there. I'm not sure how useful it will be to anybody. By zooming in a little closer here, I can show you where points A and B are a little bit better. And there's the edge of the light baffle I was talking about right there. And there's the edge of the other light baffle. There's a diagonal going to the eyepiece, and there's the place where I blobbed some ink on to erase a bad arrow that was pointed the wrong way. Also, I should mention that when you're watching a video on YouTube, you can left click a tiny icon near the bottom of the screen, I think it is, that will allow you to view the video so that it covers the entire computer screen, not just a little corner of it. Okay, so if you want to see this video close up covering the entire computer screen, you could do it that way. Sorry to be hand holding the camera like this, but in some ways it might be better. Okay, just to give you an idea where points A and B are. And like I say, there's the this light baffle would be a hollow tube right from that. That's the corner of it right there. Would be going across that way, just like a hollow sonotube or a hollow mailing tube. Same thing here. The light baffle will be in this area, all down through here, going up to approximately the face of this. And of course, you'll have to have a little opening cut on the side of the baffle to allow the light to go out that way toward the eyepiece at a 90-degree angle. With my 20-inch, I actually have this flat tilted a little bit so that the light can come up to a point right about there. And that way, when the telescope is aimed directly overhead in the sky, I'm looking at a slightly comfortable downward angle rather than straight across. It's much more comfortable. The only problem I found was that when the diagonal mirror was tilted that way, there was, because of this little opening right here in the to allow this ray to come through right here, this light to come through, this area of the mirror was actually exposed to some of the light, bright background skylight coming in at that angle. So I had to take this baffle right here and put an outside ring on it about 1/4 of an inch wider, right around that area, to keep that light from striking this diagonal mirror, because the tilt wasn't quite exactly the same. I should mention that with a flat mirror, theoretically, you could tilt it at any angle and it won't distort the image. So it doesn't have to be at a perfect 90-degree angle. So that's what I did with mine. It comes off at an angle about 40 degrees, 45 degrees, something like that. I think I've shown you that in the videos I've taken before. That's sort of a subtlety, but it was something that caught me completely by surprise, to have some flooding sky background light coming in that because I did that. And actually, by baffling the sky background really well, it enables me with my 20-inch to get really, really dark sky as a background, so that I can see galaxies and star clusters and things like that, and nebulae really nicely with a beautiful black background of sky, even though I live in a moderate-sized city. So I live in a city backyard. It borders on an open field, so there aren't too many local street lights, but the sky background is actually quite bright on most nights in my backyard. So the way to help combat that is to have really, really good light baffling, especially with a Gregorian telescope. So that's one of the little subtleties I should mention now that I'm taking up some recording time again. So my computer is warming up now, and I'm eager to download this onto the computer. So once and again, I'll say goodbye. I've shared with you some of the weird subtleties that were incorporated into my telescope. And sometime, I hope, I made a video on an old-fashioned VHS videotape years ago of me grinding the primary mirror and polishing it and doing the fine grinding as well. And I'm hoping to put at least 1 or 2 videos or something like that on within the next few months. If I can manage to convert the analog videos into digital, I'll probably put those on YouTube too. And it will give everybody a laugh to see me grinding a gigantic 40-pound primary mirror by hand. It's really a hilarious thing to watch. So anyway, I'm going to say goodbye again. I'm going to cut this off. Well, I still have able to talk because I've been talking a lot. So anyway, here goes. Goodbye, everybody, again. I'll sort of zoom out a little bit on this to give everybody an overall view of this thing. This is zooming away. There it goes. Goodbye, everybody.